I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this lecture series, we see the first topic as Vector Analysis and Coulomb's Law from the course Electromagnetic Fields. And here, from the two figure, we can understand that there is a field, and the introduction to electromagnetic fields is it is the study of the effect of charges at rest and charges in motion. There are some special cases of electromagnetics. The first case is electrostatics, and this explains the charges at rest. And the second one is magnetostatics, which discusses charges in steady motion, that is DC, direct current. And the third category is electromagnetic waves, which deals with the waves excited by charges in time varying motion. So in the diagram we have a transmitter and receiver. So if we send an information from the transmitter, it will reach the receiver by the phenomena called field. When an event in one place has an effect on something at a different location, we talk about the events as being connected by a field. A field is a spatial distribution of a quantity. In general, it can be either scalar or vector in nature. And in electromagnetic fields, the electric and magnetic fields are described as the vectors with three spatial components, and they vary as a function of position in 3D space as well as time, and are governed by partial differential equations derived from Maxwell's equations. And a scalar is a quantity having only an amplitude and possibly phase. For examples of scalars are voltage, current, charge, energy, and temperature, etc. And there is another category called vector, and this is the quantity having direction in addition to the amplitude and possibly phase. The examples of vectors are velocity, acceleration, and force. So the fundamental vector field quantities in electromagnetics, we say electric field intensity and electric flux density in the case of electric field. So the electric field intensity is measured in volts per meter, and electric flux density is nothing but electric displacement, and it is measured in coulombs per meter square or amperes per meter square. And next is the magnetic field intensity and magnetic flux density for the magnetic field. Magnetic field intensity is measured in amperes per meter, and magnetic flux density is measured in Tesla or Weber's per meter square. And there is a basic law in electromagnetics is called Coulomb's law. And Coulomb's law describes the electric force between two charges, and it is defined as it explains that the force between the two charges is proportional to the product of the charges and inversely proportional to the distance between them. And in mathematical way, Coulomb's law will be expressed as F is equal to K into Q1 Q2 by R square. And here Q1 Q2 are the charges, and R is the distance between the charges, K is the constant. And now in the Coulomb's law, when a force is along the line connecting two charges, this is attractive if the charges are opposite and repulsive if the charges are same. And it is explained in the diagram. In the first diagram, there are two charges, the same charges, they repel each other. And in the third diagram, there are two different charges, they attract each other. And the unit of Coulomb charge is Coulomb. The proportionality constant K in Coulomb's law is given by 8.988 into 10 power 9 Newton meter squared by Coulomb squared. And the charges produced by rubbing are typically around a microcoulomb, that is 1 microcoulomb is nothing but 10 power minus 6 coulombs. The proportionality constant K can also be written in terms of epsilon naught, that is the permittivity of free space, as F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. So here epsilon naught is permittivity of free space, it is 1 by 4 pi k, it is 8.85 into 10 power minus 12 Coulomb squared by Newton meter square. Thank you.